Oh.
He says that every time, doesn't he?
All right, let's take a look at what we're going to talk about today. Let's draw something. We'll draw it first, and then we'll explain what it is. So you can draw it if you like. Okay. It's not. I mean, this is just. This could be any kind of looking thing.
Is it a Pentagon?
Oh my god.
Wow. Yeah, I purposely made it look a little different. I purposely made it look a little bit different, okay? What we call this, now you've already said it. You ruined all the fun, but that's okay. You called it a pentagon because there's what? 2, 3, 4, 5 sides to it. But in general, if I have, look at and we talked about sides, look at each of these little segments right here. These are all line segments, aren't they? That's a line segment. That one is, so is that. Notice, they're not just line segments just arbitrarily thrown all over the place. Look where each endpoint to that line segment connects. It connects at the other endpoint of the other segment, doesn't it? Everybody see that? It's all connected by the endpoints. All right, so, and there's no gaps in there, right? It's not like they're open up. They're connected, all right? So, and they're not overlapping or anything like that. It's not like, let me just do this real quick. It's not like I took this and went like that, is it? Because look, this is the endpoint right here. Is this endpoint hitting this endpoint? No, it's not. All right, so oops, let's just do this. Oh goodness, that's all right. I'll just do that. Okay, so so this right here is called a polygon. It's a polygon. Gon is short for angles, and the poly, what does the prefix poly mean? Many. So it means many angles, all right? That's basically, that's the actual words, what they mean. Okay, let's talk about this a little bit more. This is a polygon because they're made up of line segments, and you've got endpoints, and they're all connected at those endpoints. Let's talk about the endpoints themselves. They have a special name. Okay, this endpoint right here has a special name. And we've already talked this before when we did angles. When the two rays came together at that common endpoint, what did we call that thing? A vertex. And we have a vertex on this as well. Not just one vertex, but how many? On this one, 5 of them, right? Depending on how many sides you had. Depends on how many vertices you have. Remember, vertices is plural for vertex. So vertex is this point right here. It's the actual point. The whole thing's called a polygon. This is a point. What about the actual line segment itself? What do we call that? You guys have already said it, actually. It's a side. Good. Okay, so on this particular one, it's got 5 sides. It doesn't always have to have 5 sides, all right? This particular one does have 5 sides. It's got 5 sides. It's got 5 vertices, all right? And they're all connected. All the endpoints are connected. There's no gaps. There's no overlapping. If you have all that stuff that's true, then you have a polygon. You with me?
Yep.
All right. There's a couple different types of polygons. We'll keep this one up here for right now. This particular polygon is called a convex polygon. Most of the polygons we're going to talk about are called convex polygons. Let me show you a little test to see if it's a convex polygon or not. If I took each of those sides and extended them out, and I'm just going to do that with a dotted line. I'll just do it by hand, so it won't be real neat, but that's okay. So if I extend this side and this side, then I take this side right here, and oops, that's really bad. That's okay. All right, I extend that side out, and I extend that side. I extend this one and this one. Here's another one. You see what I'm doing? Just taking each of those sides and extending them out just with a dotted line.
Makes a star.
Okay. Well, yeah, they'll eventually intersect, but where do they eventually intersect? At the vertex? Just like inside the polygon or outside the polygon? Outside. They all intersect outside. Look, none of these extensions, if I take each of those sides and extend them out, none of them will actually go inside the polygon, will they? So when you have that situation, guess what kind of a polygon you have? That's a convex polygon. Does it make sense? Pretty easy. So really, all the sides, if they go out like this, those extensions will never go inside the polygon. Make sense?
Yeah.
All right. Let's do one where it's not convex. Let's pause this for a sec. Okay. Now, I've got a crazy looking shape right here. Just appeared out of nowhere, didn't it? Is it a polygon?
Yes.
Yeah, because all the sides, they connect at the endpoints of all the other sides. Okay, so there's no gaps, there's no overlapping or anything like that. Sure, it's a polygon, but the other one was a convex polygon. Do you think this one's a convex polygon?
No.
No, because if I took, I'm not going to do all the sides again, but I'll do some of them, the ones that are important. Watch this. If I extended this side right here, look what it does. It does something different that the other one didn't do. If I took this side right here and extended it, look where it went. It went inside the polygon. Did any of the extensions of the other sides go inside the polygon? No, it didn't. This one does, and it does it again too, doesn't it? So if you extend one of the sides and they actually go inside the polygon, this is now not convex. What do you think? Do you know the two words? Convex and what? Concave. Good. Did you look in the book, or do you remember that word from science class? Did you ever talk about lenses in science class? You have like concave, convex, okay, the sides. You have mirrors can be that way. Your spoon, you've got a convex and a concave side to your spoon, okay, the one that curves in, like your glasses. This is the concave part, and the outside would be the convex part, okay? So that's kind of like this. If it's concave, always remember this. If it's cave, you go inside a cave, right? You go in the cave. Look what this is doing. This side, it's kind of going into the polygon, isn't it? See those two sides? They kind of go in, and so that's concave. I'm not going to spend any more time on concave. That's way too much time anyway. We don't really do a whole lot with concave. Most of the things that we deal with are convex polygons. Let's put another type of polygon up there, and let's go this one. It's not cheating because I'm well prepared. That's what it is. At least some things I prepared. So I already had these on here because I use these quite a bit. Let's take a look at this thing. This is a polygon as well, isn't it?
Yes, sir.
And I don't care about the dot. We'll use that for something else in another chapter. But don't worry about the dot in the middle. Just worry about the sides. Now take a look at the sides. Now I can't really prove it to you, but when I drew it out, I was pretty careful to make sure that what do you think is true about all those sides? They're equal to each other. That's right, and they are. Okay. If you really wanted to come up here and measure it, I guess you could, but we're not going to. But all those sides are equal to each other. If I have a polygon with all the sides equal to each other, I call that equilateral. We're going to use that word quite a bit throughout the year, not just in this chapter. We call that equilateral. Lateral means sides. The equal, of course, means equal, so it's got equal sides. So when all the sides are equal, just the sides, then we call that an equilateral polygon. We'll talk about the specific names for these in a minute. But right now it's just an equilateral polygon. What if forget the sides, what if just the angles were equal to each other? And the sides were not necessarily equal, but let's say the angles were. Now I'm not sure how I could draw that on this. I could do this, watch. Here's a situation where the angles are equal to each other, but the sides are not necessarily equal to each other. What if you had that? Let's say that's a right angle. So what kind of a figure is this?
Polygon.
Well, what kind of figure is it? This is just it's a rectangle. Good. It's a rectangle. Those are supposed to be right angle symbols. They're a little curvy, but they're supposed to be right angles. All right, I just, for some reason, it's a little bit sloppy on that. Okay, so those are all right angles. It's a rectangle. What's true about all the angles on a rectangle? They're all 90 degrees, but they're all what to each other? They're all equal to each other. Are the sides of this rectangle necessarily equal to each other? No. Okay, they're not. So I don't say this is equilateral, do I? But all the angles are equal to each other. Let's write that down. All the angles are equal to each other. So I don't call it equilateral. What do you think I call it? Angular. Good.
Oh my gosh.
Yeah. So we call it an equiangular polygon. All right, it's equiangular if all the angles are equal. It's equilateral if all the sides are equal. Well, guess what? What if both? Okay.
Double equilateral.
The sides and, I'm writing really sloppy, sorry, and the angles are equal to each other. Okay, all the sides are equal to each other on that polygon, and all the angles are equal to each other on the polygon. Like this thing right here. This thing that I originally had drawn right here. If that's true, we call this a regular. It's not as fancy, but that's okay. We call this a regular polygon. And we will have a chapter. I'm not sure exactly what chapter it is, but there is a chapter we're going to deal with regular polygons, and we're actually going to find what each of these angles actually are. Just by knowing how many sides we have, I'm going to figure out what the value of, or the measure of all those angles are. I'll save it. I know you're probably excited and you probably want to know right now, but we'll save it for when we get to it, okay? And it'll be like Christmas. So anyway, this is a regular polygon. Why is it regular? Because all the sides are equal, and what else? All the angles are equal to each other. It's a regular polygon. We good with that?
Yep.
All right. A lot of vocabulary, a lot of words that we have to learn. But they're not too hard, and after a while, you'll get used to them. Let's see if I'm missing anything else. I think I got everything right there. I got one more thing I want to talk about. Well, actually, two more. Let's pause this. Now, remember, you guys already mentioned one. Remember that first figure I drew with the 5 sides? You said it was a what? You said it was crooked, but what kind of a figure? You said it was a pentagon, right? So you guys have seen this before. This shouldn't be new to you. Let me ask you this before we get started. Can you have a polygon with 2 sides?
No, because it would be closed.
Right, it wouldn't be closed, would it? It would be open. There's no way you could close it, would it? If you just had 2 sides. Yeah, but it wouldn't be straight sides. It wouldn't be line segments in. Okay, so you couldn't do that. So what's the smallest number of sides you can have for a polygon? 3. Okay, so what we're going to do is let's say the number of sides, and we're going to have a little list here. Okay, this is going to be the number of sides, and this is going to be the name of that polygon. All right, so on several polygons, we're going to name them. All right, not every, if you have like 38 sides, we don't have a special name for that. Okay, but there are special names for so many of these things. A 38agon, right? Okay, Taylor, what was? Wow, you just raised your hand like 2 seconds ago and you forgot already? All right, let's do 3 sides. If you have 3 sides, what do we call that thing? Yeah, this isn't hard. What about 4 sides? Without looking at the book. Did you look at the book or you knew that? Did you know it? Okay, good. A lot of people say rectangle, a lot of people say square, but is every single 4-sided figure a rectangle?
Well, it could be a rhombus.
Okay, it could be a rhombus, but it could be other things as well. In general, we call it a quadrilateral. Okay, quadrilateral. Lateral sides, quad meaning what?
4.
4. Tri meaning what?
3.
Okay, you get it, right?
Why do
So-
people call the muscles in your leg quads? Because you live.
Quadriceps? No idea. I don't know much about that.
There's 4.
Ask her mom. Doesn't your mom teach
He
anatomy?
doesn't do physical
Yeah, I don't know.
therapy.
Let's keep going. I want to get this done before 15 minutes, okay? So what about 5 sides? You already said this earlier. It's a pentagon, okay, because penta means 5. 6 is a hexagon. 7, it's a heptagon, is what they call it. Yeah, septa is a prefix for 7, but for some reason they call this a heptagon here. 8 is a very common one. It's an octagon. Octagon. Remember the octomom? Because she had 8 kids at once. 9. It's kind of weird. You don't hear this too much. They call it a nonagon. Non. Did you?
Yeah, we did.
It's a A, yeah. Non-agon.
100-sided figure.
10 is one that's a good one to learn. It's a decagon. Now they have 11 and 12, but those are kind of dumb. Look at 11. 11 is hendecagon. Never
Awesome.
never heard of that in my life until this book. Hendecagon. And 12 is kind of cool too. It's dodecagon. Dodecagon. All right? And if you had n number of sides, what would you call it? An n-gon. So if you had 38 sides, what would you call it? A 38-gon. Yeah, we would just say a polygon with 38 sides. All right? Let's pause this or stop it. We'll go to the next video, and we'll deal with one more little topic.